Why, hello, you lovely people. I can see you are back for more. So we're going to do session 26 and 27. Please remember, you need to be looking into your Canvas account. Make sure that you're completing those worksheets and those activity task sheets, because that is what is going to help you. I've given you the answers for you to be able to check and direct your own learning. So let's look at functional skills here. So we're going to work out the probability of combined events, including the use of diagrams, tables, and two-way tables and express probabilities of fractions, decimals, and percentages. So it sounds like we're going to bring it all together now. So the aim of this session is to understand how to calculate probability for the equally the likely events. Learners should be able to calculate probability for combined events. Learners could aim to use tree diagrams to find probability of combined events, and learners will be assessed on their ability to understand how to calculate probability in combined events. So this table is really useful, or this chart is really useful, because it looks at the possibility of probability, and you can see here the scale is 0 to 1, showing kind of 0 as it's never going to happen, it's impossible, to 0.5 or 50% or half as an even chance, to 1 or 100% as certain. So you can use whatever mathematical formula you like for probability. It really doesn't matter. You can use fractions, you can use decimals, or you can use percentages, and they are all interchangeable. So you can do that because you now know how to do all of those things. The scale looks at impossible, unlikely, even chance, likely, and certain depth. So let's best describe the events below. So your birthday is tomorrow. Well, for me, that's a 0 because I'm born in April. Unless you're watching this in April, then it might be a bit more certain, but I'm doing this recording in November, so for me it is impossible. It will rain sometime this year in March. I think that is probably an absolute 100% certain, and the sun will shine tomorrow. Will it? Will it? We've probably had one of the wettest last couple of months known to mankind. So to me, it feels very unlikely. So down on the bottom there. But anyway, we can plot the probability shown on this graph. So now answer these questions. Which event is most likely to occur? So if we go back there, definitely probably the rain, right? Oh, sorry, we're using this chart. Ignore me. So we use this chart. So yes, obviously this is the most probable one. Then which event is unlikely to occur? So that's going to be the least one on here. So that's going to be D. Which event is most likely to occur? B. So that's in the middle. Which event is most likely to occur? Which events are more likely to occur? So C and A, because we're this side of the scale. So C and A more likely to occur. Which event is less likely to occur? Well, that's everything below C. Okay, so hopefully that makes sense. Equally, likely outcomes, coins and dice. When tossing a fair, unbiased coin, there is an equal chance of obtaining heads and tails. We call this an even chance, and the probability will be half. That is half as a fraction, 0.5 as a decimal, or 50% as a percentage. When throwing a dice, there is 6 possible outcomes, and that is 1, 2, 3, 4, 5, and 6. And each one has an equal chance. So what is the probability of throwing a 6? Well, it's got to be 1 in 6, isn't it? Because it's one dice, 6 sides, so it's got to be 1 in 6. And what is the probability of throwing a 1 or a 2? So again, if we look at this, we're going to be looking at that equation. So a 1 or a 2, because that's 2 chances now out of 6, or that could be seen. We can halve that as a simple fraction to make it a third. Does that make sense? So to throw one number, you've only got 1 chance in 6, but if it's a 1 or a 2, you've now upped your odds. So that's 2 chances out of 6. Or a simple fraction, we halve to a third. Right, here is a complete set of playing cards. Note there are 13 cards, and each have 4 suites, and the 2 colours. So that's the red, diamonds and hearts, blacks, clubs and spades. Yeah, that's a full set of cards. 52 cards in a deck. Yeah. Just my mind's wandering there. Let's go. Probability of playing cards. So now see if you can answer the following questions. If you take 1 card at random, what is the probability of getting a red card? Well, it's got to be half, isn't it? So half the deck is black, half the deck are red. So out of 52 cards, if we halve that, you're looking around 26. So that's half. So spades, so there are 4 sets, isn't there? So there's clubs, spades, diamonds, and hearts, clubs, spades, and diamonds. So it's got to be a quarter because there are 4 sets. There's a 1 in 4 chance. There you go. And the picture cards, so jack, kings, or queens, without going and counting them, I think, oh, I don't know. Let's go back. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, then it's okay. So it's 12 over 52, which would then look around, yeah, 3/13. So we've got 12 chances of out of 52 there. We're now ready to move on to finding probabilities and combination in events. Take 2 dice and throw them together, adding up a total score. What are the lowest and highest scores you can get? So on a dice, if 1 is the lowest and 6 is the highest, the lowest score of 2 has got to be 2, and the highest is 12, right? There we go. We can use what is called a 2-way table to illustrate that score. There we go. So you can see here, the table shows the complete set of outcomes when we throw dice. The most frequent is 7, and the least frequent is 2 or 12. When summarized, the frequency looks at the number of times each total occurs along the diagonal. So here. So there's more chances of getting those than what there is of those. So here, the probability of a combined event, we summarize the frequency by looking at the number of the tables occurring along the diagonal. So here you've got the totals there, and there you've got the frequencies. So can we use the table to work out the probability for each possible number? This includes using this formula. Probability of events, so the number of successful outcomes divided by the number of outcomes. So what is the probability of throwing 8 with 2 dice? Okay, so you can see you've got 5 there, so 5 over 36. And that's because if we add that frequency table up, it's out of 36. So there is 6 times 6 equals 36 possible outcomes. For each one is equally likely to occur. So we can put that as P, 8 in brackets, 5 over 36. So this is the probability of fractions. So you can see there. So what is the probability of throwing a score of 6, 7, or 8? So throwing a 6, a 7, or an 8. So you've got the 5, the 6, and the 5. add that together equals 16 over 36. Turn that into a simple fraction, so divide it on itself, and the simplest way you can do that is 4/9. Good. So probability of combined events. 2 coins are tossed together. What is the probability that they both land heads up? The two-way table will help you find your answer. So here you've got head, 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 tail, tail, head, tail, tail. So the probability then is 1 in 4, isn't it? It's got to be, because there's only 4 possible outcomes. So it's still got to be a quarter. Yeah, does that make sense? So we've got 2 coins. There's your table. This is the amount of combinations that you can have if you flip 2 coins. But ultimately, it's still a 1 in 4 chance that both will land on head, head or tail, tails. So the coins are tossed together. This is the probability that both land heads up. This time we'll use the tree diagram to solve the problem. So the first coin can go heads, the second coin can go heads or tails. Outcome heads, outcome head, tail. This first coin flips as tails, so it can come as tail head or tail tail. Yeah, does that make sense? So we're showing the probability of the coins being tossed there. So from the diagram, we can see there are 4 possible equal likely outcomes. The first coin head, the second coin head. First coin head, second coin head, tail, tail head, tail tail. So again, showing a 1 in 4 chance. So what is the probability of getting 1 head when 2 coins are tossed? So here, we've got 4 chances. We've got, so 1 head there, 1 head there. So it's got to be out of 4, it's got to be a half, right? So a half. Good. So by the end of the session, learners must be able to understand how to calculate probabilities of equal likely events, calculate the probability of combined outcomes, use the tree diagram to find probable combinations, and understand how to create problems and combined events. Please make sure that you check your skills and do your knowledge check. Lovely. Thanks for watching. One more to go, I believe.